Hey everyone, this is Sina with another episode of Into the Bytecode. My guest today is Andrew Miller. Andrew is a professor at the University of Illinois at Urbana-Champaign. He's an associate director at IC3. He's a board member of the Zcash Foundation, and he's also currently working with the Flashbots team as a visiting researcher. So the topic of our conversation today were trusted execution environments, and specifically how we can use them to do account delegation and access control, and how this seemingly simple idea can have far-reaching consequences for the future of the internet. We also talk about how Andrew thinks about doing research, how he kind of prototypes to get a handle on new directions, and we also talk about what he remembers from the early days of Bitcoin, as someone who's been around since 2011 or even before that. I hope you enjoy. Yeah, so I think today we're going to primarily talk about account encumbrance, Web2 accounts, the permissionless delegation of them using TEs. But I thought maybe before we get into that, kind of starting with some background and origin story, and in particular your own kind of path into getting interested in this particular problem, because I think it has some history, especially kind of looking back on the 2018 paper with Delegate, but also more broadly, trusted execution environments and how you kind of got interested in them as a direction of work in research. And yeah, feel free to weave in as much of your own personal thoughts here. I'm really curious on how you kind of got pilled on this broader concept.
Oh, that's awesome. Yeah, I mean, because you brought up the Bitcoin unboxing videos, I can talk kind of about the longer personal path of me getting there. I was really early to Bitcoin research, in 2012 and 2013, and was really interested in the expansiveness and disruptive permissionless innovation that you can see kind of being possible with smart contracts there. I think it was pretty clear from the beginning that privacy is in conflict with the kind of ease of expansion. So I spent a bunch of time doing research directions like in consensus protocols and then in zero knowledge proofs, but that only kind of added a little bit of flexibility to what smart contract developers can work on. And I view smart contract developers as kind of the most interesting unit of low authority permissionless contribution. You can make a DeFi instrument with nothing but some Solidity code, and it essentially becomes the most decentralized thing that can run. So that's really powerful and exciting. But even with Ethereum and other flexible smart contract systems, without flexible privacy, without the kind of full programmable privacy that TEs give, you're only able to explore this kind of tip of the iceberg of the design space. You keep getting stuck in kinds of mechanisms or interesting things you could do. I remember having I don't know whether I've told this story much before, but I got impressed on really early at this real world crypto conference in New York. And I think it was Jonathan Mohan who gave this really impassioned pitch about Ethereum, pre-Ethereum launch to this crowd of, cryptographers, people who, applied cryptographers, but still, cryptographers. And so funny that the narrative didn't quite click then because it was, too early ahead of its time, but it focused on Ethereum as like a host for fully autonomous replicating, autonomous agents. And you can kind of see, smart contracts as exhibiting some qualities of autonomy. At least they're, hard to, shut down on their own. So they've achieved this kind of level of decentralization, but, still the cryptography hadn't caught up the time. And then, for some technical reasons, which I think would discover, pretty well all of those, but, could recap any of the trust model around TEs. They're kind of uniquely good at providing this really, flexible way that the full design space of, stuff smart contract developers might permissionlessly develop now can handle, access to private data, whether it's private bids. That's obviously a fit for mechanisms in AMMs, but also it can be private, account credentials. So that opens up all of these, other interesting avenues. And it can also, you can now flexibly imagine being able to write, AI agents with private state as well, and manage those. So now even things like that are now maybe addressable by the kind of permissionless developer teams, that make up the contract developers in the ETH ecosystem. So yeah, that kind of links the, interests all together.
So you kind of from the beginning intuited that the lack of confidentiality was going to limit what's possible here. It's actually kind of crazy that all of the applications we have in the blockchain world are all entirely transparent, right? Like everything we've built exists despite that very important limitation.
Yeah, absolutely. And I mean, it either comes across as like, an inhibitor to adoption in some ways. So like the premise of healthcare on the blockchain, never could get that far without a story for how to manage, obviously necessarily private data. I mean, in other business or business to business applications, I think there are similar stories there about actually being an obstacle to adoption. But yeah, it's also surprising that people go just so far with, being willing to, do these applications in a fully transparent way. I think that there's a sense that, that party can only go on so long, and then there will be a, reckoning, whether it's, AI expanded bulk surveillance or something like that. It's not exactly clear where the consequences of oversharing. So it's not that there's not adoption, it's that there's too much adoption without the privacy guarantees. So, who knows exactly how that will end up. But yeah, I mean, I guess I would say my sequence of things is I spent several years trying to focus just on what you could do with zero knowledge proofs. And then maybe from 2018 to 2022, absolutely bet on MPC being the way to do it, and pretty much just, ignored for the most part, trusted hardware, except for that observation that, by combining account credentials with trusted hardware, you can get some really surprising applications as a result. And yeah, then that wave of, talking against the T narrative, kind of started for me around 2022. And I think that's been working. Now there's more of an interest in these. And I think you covered the trust model and the thoughts that led to that narrative and the finer points there, pretty well. So I guess I'm most interested in returning to this. Like, let's say that we have the trustless TEEs, or, for whatever the scope of this, it's a reasonable, acceptable choice to build decentralized systems that are, making use of the full expressiveness that TEs can do. What are the most interesting applications? Either things that are, we just didn't think of before, or things that are actually ready to cross some kind of chasm of usability, so they can be, good usable products early on. Yeah.
Like almost take that as an assumption that we have the trustless TE, and then start to imagine where we can go from here.
Yeah, exactly.
Maybe before we get into that, just since you were focused on MPC for so long, what do you think of MPC, practically speaking, when it comes to implementing these sorts of applications? I know there's kind of performance questions and things of that nature. There's things around, okay, these different participants may collude with each other, so you have to kind of update your trust assumptions. But if you were to give someone who's somewhat familiar with these different threads that may be able to unlock similar sorts of possibilities, how would you characterize where MPC is at and how to think about that?
So I might break it down this way. There's three kind of components of MPC that are relevant. There's the expressiveness, like how you program it, the performance, which we can talk about. Obviously, that's technical, and then the trust model. And also there being a short answer that you can always combine MPC with trusted hardware. So maybe I would just start with the trust model. So to me, the main concern with MPC is that in the model, there's many ways of doing it, but generally you have this dilemma between availability and privacy. It's like the more nodes you tolerate for availability, like you don't want one node to crash and take out the whole system. But the alternative forces you to say, well, this many nodes could collude and undermine all the guarantees I was, relying on MPC for. And so this is the collusion problem in MPC. And combining trusted hardware with these is a great fit, because you can say, well, our concern about collusion is that these parties might just be tempted into decrypting everything or being easily bribed to help decrypt everything. And all the mitigations kind of against that, I would say, are kind of partial, or also rely on like, crypto economic assumptions, or setting up like entrapment clauses, kind of more complexity. And all of this is completely far away from mathematical cryptography or, hard assumptions, anything like that. It's pure, it's the more complicated kind. It's more crypto economics and all the, fuzziness that may entail. So why not strap a trusted hardware on the MPC nodes as well? So then they're, only allowed, unless they can break their trusted hardware, they're not even able to do anything except participate honestly, and only decrypt while they should. So yeah, I mean, to me, that trust model issue may alone have been a good enough reason not to, pick multi-party computation, at least for the full kind of, flexibility of apps and getting to, have a shot at staying relevant to this AI, agent kind of direction, which, good luck doing that in MPC then just for performance. I mean, and maybe something like, we worked for a while on the expressiveness of MPC and smart contract programming. And I think that, MP speeds is great. It's like a Python language that compiles to MPC. And, that's somewhere where, ZK tools were, a little bit ago, maybe the same way that there were ZK VMs, kind of like an expressiveness, improvement to the way that developers in smart contracts world use ZK. It's easy to see that there can be, improvements on that kind of experience for MPC as well. So I know Mikura and Stoffel MPC are working pretty hard on, some blockchain capable MPC, framework. So I think that these are promising too, but that there are some limitations that you run into. Like I think that places where you need private accesses to data sets, it may largely depend on how acceptable, it is to do sender receiver linking. If, you're using such a platform to do, just say blockchain, digital asset transfer transactions. Basically, there's some need for oblivious RAM in a system that's, FHE based or MPC based. That's something that's going to be fairly difficult. So I think the applications that make the most sense on those systems kind of, they're clearly accepting some constraints by having to work in this, MPC domain that may just force them to say, well, we don't handle, private access patterns. That's just a constraint on the applications that, we express. And so, I think that kind of ease of expressiveness is now one of the things that's just really, in TEs, the expectations are so far that the concern of engineers is completely different, because now the story is like, our expectation is that nearly any legacy software package, just containerize it and it's going to run in a trusted hardware in a meaningful way, like taking advantage of the, raw primitives that the trusted hardware has, like attestation and everything like that. So, not only is it like it shifts the discussion, but it's like the whole,
you can actually permit yourself to think about applications on what you would build.
Absolutely. Yeah, exactly.
Yeah. And before we get into the applications, like when you think about the trust model of a TE and the threat vectors and the stuff that I talked about with Quintus, I mean, he kind of characterizes it as, being in these three buckets to think about, like remote software attacks, attack vectors, physical, like hardware attack vectors where you have access to the hardware and you do side channel attacks and things like that, or supply chain attacks. And what kind of strikes me about the work that he and others and you are doing is that how kind of clearly you've broken out this roadmap into sizable problems and, steps that come one after another. But it's also like a very kind of like big, ambitious undertaking. So when you think about, okay, we can assume that we have the trustless TE, and then what do we build with it? Like, where are we in practically being able to make that assumption? Like, how do you guard against that? Especially if we're kind of talking to other builders who are starting to think about building with TEs. How do you think about what trust model you're practically buying into? What the kind of like timelines behind that are? What are the like different things you're watching as they're kind of like getting developed?
Yeah, I can try to give, um, my answers probably have like two tangents. So one of them will have to be about the software mitigation approaches, that's kind of on the software and, integration engineer side to deal with. And the other one might have to do with, I mean, I guess the case for, compromise in some way. So like, yeah, this effort of trustless TEs is, I think, a pretty remarkable effort. That is super ambitious, being able to even, make it seem approachable and like there might be a path to this. That's, a pretty important, case for, I think, giving us a good reason to believe that we won't build up too much dependence on this just at the, concept and preparing for TEs level. There's, I guess I would speculate that it's possible we're at like a really, good time for TEs where they are effective against bulk surveillance. It's impossible to rule out whether, even like bulk surveillance would be, something that's thwarted by these or not. Maybe that's something that changes, even if it is, good right now, it might, change in the future. I think what we can say is that even right now, the TEs are being really effective at practically preventing, protocol designers from being able to, use TEEs, but expect to be able to just actually have a business model that's based on, surveilling or rugging their customers in a way that the TE could catch. Because it's hard to, make a plan that relies on you being able to effectively exploit
Right.
TEs. And then there's a whole host of other mitigations that I think, suggest optimism for most apps now.
To some
Yeah.
approximation, they do work, and you can't just like assume that you're going to be able to look into them and like have a plan around looking into them. It's like very hard to compromise them.
Yeah, I mean, I remember thinking of, I would give this talk a bunch about CryptoKitties, how it's the perfect, example of disintermediation, because you don't have to trust the developers. They'd be way in over their heads for, all the details of running an auction. But if the auction is so simple, it automatically runs. You're disintermediating the very low trust actors, which are just smart contract dev shops, and lowering the barrier to entry to those. That's the best way to get, the full permissionless development of apps. And so I think it's the same, kind of story here. Yeah, let me pause a bit. I think I had something else to say, but lost my train of thought there.
I think you were talking about there being two different ways you think about where TEs are practically today.
So in general, it's also early with application developers using TEs. I guess one thing I'm worried about is there may be a period where you just, the XKCD that's just attached, random garbage at the end of your email and say it's a PGP signature, and it looks like you're using encryption, and who's really going to, inspect the random thing. We may go through a phase where it just becomes, oh, here's my remote attestation. It's an even longer page of, base 64 junk. So, there, I'm in a TE, I'm secure, I'm unruggable because I just show this. And, we're not even at that point. So even just saying, where's your remote attestation for now already, separates a bunch of T apps. But, we may go through a phase like that. That's not all there is, to it. There's more to catch up. So maybe it'll be borne out or not, whether developers, actually have to do the right thing, at least in their design of the protocol and their ability to carry out backdoors. So we'll see if that holds, but I think that's what's set up to do well. But we're, I don't know, developing even software best practices and like release management best practices that work with remote attestation. That's still ongoing. Flashbots is doing a lot of leading in that, but that may be where that goes. Yeah.
Yeah, that stuff's pretty cool. Like where you kind of use an Ethereum smart contract as like the version manager, and like the T is like following. It's like picking up the latest hash from the smart contract and then like installing that program basically.
Yeah, I'm excited about anything that involves TE software, with a light client in it that follows a blockchain. This is that coprocessor model. It's really cool. I did want to say something else about the trust model T is about the cloud model. So I think that maybe one of the most important reasons for optimism now about the use of TEEs in increasingly, important applications is it is a trade-off with decentralization, but it's the ability to basically say you have to be an enclave-based node and you have to be resident in one of, say, the top 6, clouds or, providers. it's a compromise for decentralization because you're saying, have to be using these, white glove, things. Maybe that raise costs. That clearly puts them, in some kind of point, but it can still at least be essentially a zero knowledge, membership proof. You're in one of these clouds, but you don't have to divulge which, and you may not even be revealing much about that you're even using the trusted hardware on these, especially in a world where like all the new Intel chips have this support, or if it just becomes totally ubiquitous, then that becomes not so much of a restriction. Yeah.
Right. So it's a compromise on decentralization, but at least we know that the person running the TE doesn't have access to the physical hardware, which is like adds a layer of security.
Yeah, and it kind of maybe even a way to think of this in the framework, it separates the physical attack space of it, and maybe some way to think about it is that not all physical attacks are the same. There's somewhat more, attack surface. The crypto economic reasoning of security and reputations of these data centers, I do think is relevant, and so making it harder to carry out even physical attacks, counts as well. And
they have a lot at stake. I mean, they're not going to go, they're going to do everything they can to prevent one of these TEs from being exploited.
Yeah, exactly.
Okay, so kind of going back to the fun question we were beginning to entertain, which is, let's assume we have the trustless TEE. Now, what is possible? And when you kind of let yourself riff, go diverge mode with maybe, not bringing in the rigorous, like what works, what doesn't work, like tearing these ideas apart with more of their details. Like, what is possible here? Like, what space does this open up?
Yeah, that's what's so interesting. It's like, what can you can put anything you want into these T's. What's the most surprising things you can put into them? You can put, secret thoughts and, I don't know, try to make a clone of yourself in it. I think that the most interesting, consequences derive from this idea of what if you put access credentials in the T's. Actually, it's a short connection to the, trust model from before, but one of the easy things to say is like, well, at least you don't just put all your spending authority, like your entire private keys in the T, use them for these short-lived privacy kind of applications. So managing an auction's one thing, holding your wallet in a TEE on someone else's server, maybe that's, a lot riskier. And if you really open up to, well, so what, if you put just private keys in the TE, what, can you do with them? Actually, yeah, Quintus gave a good description of the quantum cache. And, if you're willing to put private keys to digital assets in a TE, then you can get these kind of really fast payments and off-chain, interactions. So, that's sort of interesting. That is also, it's not, you can see it as an improvement to the performance of just digital asset applications. So I thought it was really interesting to start with the idea of putting access credentials into trusted hardware. And this is where the I think in this delegatee paper, we thought that this would be able to make a really disruptive kind of marketplace. Like you could, share your Netflix password, but in a way that lets you just share it for one night and for one use. So it would be like turning Netflix into, movie rental. And we explored this in a couple of other directions. One way of thinking about it is that it solves this delegation problem. Like delegation is really useful. A lot of websites now support delegation. Like you can make read access, read write access. But then there's nothing in between. You either have no ability to write, like a read-only access, or you have this unlimited ability to read and write, but then that's more sharing that you wanted. And it's, risky to give away your Netflix password because then they could even change settings and such. So it's nice to be able to bring this, fine-grained delegation where I can say I could just give you my password, but instead I'll only let you borrow my password and use it in a very limited way. It's useful to be able to have these extra delegation points in between. And then what's really surprising and disruptive about TEs is it proposes this kind of permissionless composition approach to improving delegation, because you can say we don't need to wait for Netflix to provide this kind of sharing, and for obvious reasons they don't want to promote that kind of sharing. But because it makes use of the user's own authority, the idea of putting the access credentials managed by trusted hardware, it allows you to implement this kind of user chosen filter on top of what they could already do, and that's enough to carry out these kind of features. So it's kind of an interesting way of bringing disruptive secondary markets to places where they wouldn't ordinarily be in range of blockchains and digital assets to kind of manage them.
Yeah, it's like a way to wrap around existing services in a way that they can't prevent, right? And to like make it super concrete. Like a really simple example would be that you the teleport example with how you put Twitter credentials inside the TEE. And do you want to just talk through like very concretely what's happening there?
Yeah, so Shin basically working independently spotted this kind of cool approach. I mean, people started playing with these smart contracts running in TEs for a while, but very quickly wanted them to be able to reach out and touch Web 2 services and make web queries and other things like that. And okay, so you can see this idea of one-time credentials for social media posts. So this works with Twitter's read-write delegation ability. But just like the Netflix example for delegatee was one night for viewing Netflix, Shin's example was a token that lets you post once to Twitter. So you can share just a portion of your account with someone. Essentially, you can get a code that you can just pass around in a URL that entitles whoever is holding that code, that URL, to post just once from your account. And the way that this works is it wouldn't take much to just make a web service that does this. There have been some products as well that are services that do things like this. Twitter supports this read-write, so you just have to run a service that says, trust me with this read-write ability, and I'll make you these codes. What's really interesting is to be able to use the trusted hardware to lower the amount of trust required to make that, us actually follow that policy. So the trusted hardware provides this whole remote attestation. You can interact with that remote attestation before completing that authorization flow, or rely on a kind of deferred audit log. We make use of certificate transparency as kind of a place where all the certificates that could serve our domain go, and we have on our GitHub a remote attestation that explains the public key. It's like an alibi for the public key in every certificate associated with that domain. And so either of these allow you to basically get more trust that the service actually does what it says, namely that it's not rugging you by excessive use. Like we claim to only do one post every time you approve a new post, but how would you take our word for it? We could just be selling off advertising rights to your account and posting secret messages when you're not looking.
You don't know if it's changing hands.
Yeah, liking people, following people without you noticing. But we can provide this audit log and proactive defense using the trusted hardware to show that works. And then there's something really appealing about the kind of actualized decentralization, not at the infrastructure layer, but at the user interaction layer of posting from each other's accounts. That's pretty appealing as well. And adding yet more to the kind of permissionless innovation, permissionless composition that kind of this fits. We kind of just use base as the append only log, like that. The T follows the blockchain with its client, and so one post is one redemption event on a smart contract that tracks these, and the smart contract is 721 NFT compatible. So OpenSea recognizes it, so all of these teleports are automatically transferable digital assets on OpenSea that are backed by the ability to tweet from an account. So they're, in a sense, they're a very purist kind of self-describing digital asset that blends this reaches from Web 3 to Web 2.
Yeah. Let me retrace like exactly what's happening to make sure I understand it. So we have a TE running on a server somewhere, running a program that basically has this ability. So I go on Twitter, I log into my Twitter, I add this program, I give this program the ability to read and write from my account the same way that I would do with any other third-party service. This program basically keeps that ability to perpetually read and write and exposes it to its own users in the manner of like, you're only allowed to post when this particular condition is met. And then that condition can be anything that you want. It could be a secret code that someone has and puts into a URL, or it could be that you have to prove that you hold this particular NFT. And I could go and create this NFT that says whoever holds this NFT can make one post from my account per day. And then, the TEE inside of it would run a light client, which basically gives it the ability to read the state of this NFT smart contract. And once a day, it's like, okay, like the buffer has refreshed. Anyone's allowed to post. When someone goes to post, they have to sign and somehow prove that their account is the holder of this NFT, and then they can make this post. And because the TEE can do this remote attestation, I know that this is exactly how it's operating. There's no kind of like third party that I'm trusting here. And it's this very kind of like elaborate, expressive mechanism that I've just encoded into a program that's running on the internet and interacts with my Twitter account. That's kind of crazy.
That was a perfect retrace of it, but yeah, exactly. That's the appeal.
Yeah. So where does this go? I mean, so we're doing this with Twitter. That's pretty cool. I'm kind of intrigued by doing this even for my own Twitter account, but slightly scared about what people might do. But also what's cool is that you could add an additional step in this program that does like some level of filtering. And it's like, I will only allow posts to go through that, meet this regular expression, or use an LLM to say that it can only be about this particular topic when someone's posting. So we have full expressiveness around what this program can do. But I feel like this is only kind of like an evocative toy example. What does this really mean? Where does this go when we play it out, a couple of steps from here?
Oh man, I mean, so I think that the most important mode is just that there is this expansive design space, and I think a lot more surprises, yet to uncover these. You can kind of play the game of going through any possible account type. It's like all of Web 2 becomes open, and you go kind of one data silo or, provider of authority or, composable service in a way, and then see, what can you get if you can make private digital assets, on top of it, or otherwise, combine them in some way. And I can try to go through, a few different ones. There's one that's at the top of my mind because it's a really good, gentle entry point. Clearly, a lot of these are more spicy than others. And in terms of playing it out, there's like reactions of, Web 2 providers, or especially identity providers that, might be spooked by this. So I think there's definitely an interesting line to follow of basically advocating for the most constructive uses, while there's still a chance for that to be the ones that catch hold and set the pace for it. So there's a category that I think is interesting that's like compliance oriented ones, and the one that I think is the nicest example, because it's like I think this is pretty non-controversial, is this package supply chain sub-delegation. So I can give like two kind of discussions of these applications that were Twitter thread jams. This NPM one on package supply chain is from Will fuckery.eth, the TEVM guy. And, NPM, the JavaScript ecosystem is, pretty usually like it's earned its, being mocked for, shoddy supply chain qualities. So NPM is this, service that's the, package manager, manager. And, you can have accounts on that to manage a project that's on NPM. They actually do provide a whole bunch of tools for setting up, 2FAs and role-based accesses. They actually do a fairly thorough job of sub-delegation and, good or authorization expressiveness. But there's still some limit to what they've provided. And so the ability that you could add additional covenants or additional restrictions on the developer account by putting the developer account in a trusted hardware. That's super interesting. It kind of follows this pattern of, it's not that I'm giving away my account, it's really just I'm accepting,
more constraints,
more constraints on authority that I already had. And this way you can attach a plausible policy that it could range from, I ran this static analysis tool on the code I'm about to check in and it didn't say anything, to things that are like smart contract, like I have a notice period, it has to be on a data availability layer and pending for 7 days as measured by a TEE-like client watching Ethereum chain. And, after that time window, then it can switch to being, published or not. Yeah, exactly.
Wow,
that's a cool way of being
super interesting. Mm-hmm. So it's like making me think that this idea is maybe as broad as just like, I don't know, smart contracts, like just basically any kind of like contract that I'm entering into with the world. Some of these can be expressed as like, blockchain oriented distributed programs that run on this like distributed virtual machine. But this allows us to, does the idea of account delegation kind of, is it as just by kind of like constraining what this account can do? I mean, that's in some ways constraining what programmatic actions can be taken, right? That feels like a very expressive, like broad ability to have.
Yeah, it is broad. I mean, maybe then a way of tracking towards more nuance is the following. So first of all, there's lots of cases where you want to prevent this, and then things that you could do to inhibit this ability to do delegation. And there's also a notion of limits to encumbrance. So I think the right way to think about it is that all account encumbrance is partial in some ways. And this isn't even about TEs being fragile now, but it's about, we're talking about encumbrance of Web 2 accounts. So Web 2 is characterized by brick and mortar somewhere. There's a CEO of every Web 2. And so you can call the CEO of any Web 2 account and get your account reset somehow. They really vary in terms of their policies of how they do that. And a bunch of services are just known for being like, oh, you lost your GitHub codes, like enjoy your new GitHub account. You won't, like, we just don't provide recovery as a service. It's easy enough to create new ones. They just leave you on your own. And so you can imagine taking measures to basically improve the encumbrance. Like in a way, even the story with, say, Twitter is that Twitter has mandatory recovery set up. Like you have to delegate some external recovery ability, either a phone number or an email account with Twitter, never just password alone. So to encumber Twitter essentially requires you to also encumber either a phone number or an email address. And you have to, encumber in Proton Mail or some other email provider. You have to do the same thing until you get to a root. There's kind of a encumbrance graph covering, problem if you view these kind of composed that way. But it's all, at the end of the day for Web 2 accounts, there's some subjectivity that just comes from the way that, Web 2 accounts work. So that limit, this is imperfect, but it's a question of where where it's an appropriate use for the, risks that are involved.
Yeah. How kind of deeply coupled do you think this direction of ideas is with AI agents existing on the internet? Because in some ways I feel like the substrate that an agent exists on feels like must have these kind of integrity and confidentiality guarantees that a TE provides, and to also, I mean, if we're talking about alignment and things like this, but at least like somehow constraining the space of like what's possible, these encumbrances feel like a potentially important tool there.
Yeah, definitely. I mean, there's we kind of forked the conversation there. There's the role that encumbered accounts plays for AIs. It's totally I think Shin's pointed out for a while that we should think of these accounts as like a really interesting substrate for agents to use. So having agents associated with Twitter accounts is already a pretty a trend that has caught on, and can imagine that the ability to delegate to AI agents makes a lot of sense, and that AI agents with accounts may be delegating to others and pick up on the more complicated kinds of composition. So that's one direction. So account encumbrance of Web2 data sources, for example, might be really interesting for AIs to use these accounts. I think there's also a story that's is pretty clear that AIs are useful with access to sensitive data, and also that there are uses where an aggregate view of sensitive data from users would be really useful, and where the distrust, is actually one of the inhibitors to getting this kind of use. So I think that the trend will basically be that for AI applications in general, it will just become ubiquitous, that there's this level of integrity and some privacy and isolation and assurance that you get from it. I mean, and this comes from just the the NVIDIA GPUs support some kind of TEE that works in conjunction with the CPU drivers, TEE as well. So those come together as a assurance compute system. It's a reasonable prediction that just clouds will have this for, especially if you're willing to pay for it, or if it's AI tier and already expensive, then it's maybe even more likely that that'll be early adopters of this, and will buy up. They'll be the ones that are buying up all the the secure instantiations of that. So it may be that it just becomes something that's pretty quickly expected and deployed everywhere. I guess that to some level we'll see. I'm really interested in and this is, I think, kind of open. I'm still not sure quite, best how to think about it, but I'm really intrigued by the way that these contests have evolved, that are like TEE agents that have some kind of, there's some contest quality. Like Freza is the really popular one right now.
So cool.
And it's kind of an instance of some other games that, academics had talked about, or News Research had this Turkish rug salesman kind of game that wasn't like loaded up as a contest in exactly the same way over Twitter and with payments to enter, but it's, either try to be persuasive, figure out how to be persuasive by, getting an AI to reveal information that it has, or essentially prompt break it, somehow. But there's some element of privacy. So typically the arrangement is that there's a developer who has the hidden prompt, or it's like proprietary components of the prompt. And even if the rest of the agent is, open source in some way, even the prompt is what's, hidden. That's the thing that's, that holds the secrets that if you knew them would make it a lot easier to know how to break it. In the case of Freza, I was just reading this thread today, so this is why this is on the top of my mind, but haven't, fully digested it yet. But the winner of Freza has now gone through a couple of iterations. So this was a tweet thread from the winner of, I think, the third of them. And it was like 2 sequences of breaking it. The first sequence was a friend of his that got it to output its system prompt. So the system prompt was initially, private. Only the dev obviously knew, whatever admins of Freza knew, but it wasn't publicly visible. You get little details about the system prompt, I guess, just through ordinary interaction with it. But if you, really get it to, delimiter, escape, whatever, you can get it to output the system prompt. If you have the system prompt, you can grind, because the way the Freza game works is you have to pay a little to chat with it in public. So you're limited in how many shots you can take.
But then you can run the system prompt on your own server.
Yeah, you can grind like an offline attack if you have the system prompt, and then you can figure out what it's, what secret, what things work on it. And that, and then the second step is then, actually saying the right things to get it to actually carry out the action of, sending the transaction. So that's how that was broken. But I'm fascinated by what role TEs can play here. So the first thing that stands out at me is that there is still this information asymmetry where the developer is not like the mechanism designer of a smart contract auction. They're more like, they have this, obscure prompt, hidden prompt. And so at a minimum, the dev has this insider information to begin with. They could give people a head start on hints. So if there are like a lot of, continuing demand for games of this kind, to actually say, well, we're going to use TEs, and the TEs are going to guarantee that it's, unruggable in some way, or the game is not rigged, then we'll have to be more thoughtful about that sort of thing. And it's not clear how you can just take Freza and make it a fair game with no insider information.
I mean, these feel like kind of good threads to pull on, because I mean, as the saying goes, things start out by looking like toys, and then before we know it, there's like a lot more on the line. And these Twitter games, I mean, it's just so cool. Also, I realized, I think yesterday, that Fresa might be a riff on Fresa, which is like strawberry, which is that true? Which is like kind of a meme right now.
That's news to me. Just
Yeah.
strawberry in general is a meme.
Well, I don't know exactly what the backstory was, but OpenAI's latest model was kind of nicknamed Strawberry for a long time. So, like Sam Altman was like tweeting photos of strawberries in his backyard and being like coming soon or something like that. So it might be a nod to that meme.
Oh, it went over my head, but that's pretty cool.
um, one more kind of technical kind of like architecture question that I feel like might have interesting ramifications is, I saw you've been working on this project called Dstack that kind of puts TEs into more of a peer-to-peer architecture. So why have you been doing that, and why is that an interesting direction to go in?
Oh yeah, and this is fun to talk about. So yeah, I mean, I would say this is the third kind of architecture thing I've worked on since starting my sabbatical. I mean, I guess we didn't go into after the MPC. The topic I was most interested in was specifically smart contract based programming platforms using TEs. So worked on this 2019 paper, Ekiden, which became the basis of Oasis. And so this is TE-based smart contracts. It's kind of just you run virtual machine for smart contracts inside of a trusted hardware. And now you have to add encryption of some kinds in it. There's more to it, but you pretty readily get, a private smart contract system, smart contracts with confidentiality. And then there were a bunch of instances of these, like Secret Network especially, and also Fala and a couple of others. And these really developed while I was still kind of betting on MPC, and then only came after these, but then became really interested in how to improve the architecture of these, especially to do their part of the platforms built on these have a lot of the burden of mitigating the problems with TEs. It's not all just expect Intel to fix everything. There's a lot of integration work to do. So I was really interested in improving the best practices of these smart contract platforms. Then I helped with Flashbots do this Suave Sura like EVM-based coprocessor. I also helped the Informal Systems and Cycles team do this Quartz sidecar kind of architecture, which is a bit like the COSM-WASM related approach. Being a sidecar versus a coprocessor have some like really nuanced differences, but it kind of is, how much of the package and instruction set does the app developer bring versus is already done, and pretty negotiable on both of those sides. But for a bunch of reasons, one of which is just going with the tide of like the move from SGX to TDX, and the fact that TDX and AMD and the Amazon Nitro T are all container based rather than process based. It's like SGX and the first cohort of these fully programmable Ts based in SGX. That's process based, so it's like untrusted OS kernel and trusted enclave process. And now the trend that's far more adopted now is the confidential virtual machine. So it's like untrusted hypervisor and other VM tenants, but you can have a VM that's running in this isolated mode. And there's a whole bunch of nuance in the different burden of software developers and how the auditing responsibilities break along different kinds of modular lines. But really the thing that matters is just that it has a much easier developer experience, and you get a lot further if you set your you want to have access to remote attestation, and you want a legacy code base to be running in this enclave. That generally works pretty directly with TDX and with those other systems as well. Especially if you can containerize your application, then you can share a common base image. Maybe this is hard to explain, but maybe I try just to get in this level. So the basic structure is like TDX and these other systems at their low level, they're the secure support for secure virtual machines. So you have to bring a kernel and everything that fits in a virtual machine, RAM disk drivers and such. And that's the unit of a secure, thing that this requires you to then essentially audit the kernel. So Flashbots is specifically using Yocto, which is like a tiny security-oriented embedded kernel. So it's great for a VM, and it makes sense for this approach. And it comes along with its reproducible build scripts, and you continue using these. But then the idea is to say, well, we're going to make a base VM that is application neutral. It's just a Yocto-based base VM, and it has a couple of raw utilities built in, like the guest driver, so you can ask for remote attestations. Not a whole lot else. Mainly, it then just also has an implementation of a container driver, so Podman, gvisor, something capable of running kind of standard containers. And now application developers you just have to worry about packaging up your, system, service, node, whatever, into a Docker container. You have to bring reproducibility for how you do that. If you have a whole build chain, you may need to make your app binaries reproducible and, put them in a standard base image. That's the level that has to be specialized. So it's a good way of factoring out the things complicated to do these. And so in a nutshell, Dstack is this kind of, there's a bunch of people working on a close enough related goal that this is kind of I made this kind of quick prototype and baited Fala into spending a bunch of time developing a full version of it. And meanwhile, Flashbots was doing complementary work on kind of doing this hardened Yocto image and making sure it's performance capable and able to run the builder. And so broadly collaborating on these. And in turn, there's a bunch of other projects like confidential containers and what else was I going to mention? The other things that are based on containers as a kind of development interface for this. I would say that our version is focused on being fairly approachable, and it's meant to be able to be looked at, and it's not about hiding everything behind just an interface, but making the whole thing fairly straightforward to follow, because we have to upskill security auditors and even people critically minded like that anyway as part of the whole effort for this to work.
Yeah, that makes sense. So in a way, kind of like abstracting away more of the low-level complexities and allowing the application developer to just bring their Docker container and their build script and only have to worry about that.
Yeah, exactly.
Yeah, very cool. For our last 30 minutes, I had some kind of like more fun personal questions if you're up for it.
Sure.
Related to these topics.
Yeah.
But the first thing I thought to ask you is about research and kind of making progress on new directions of work that are, very kind of like undefined. You kind of like intuitively sense that there's something there. There's this like curiosity pulling you towards them. But it's very unclear, if there is something there, how it's going to work out, what even the steps to take are. So I'm curious, as someone who's been doing that for a long time, and maybe if you kind of put yourself into the shoes of you're talking with a new kind of grad student who's setting out to do this, and they not only want to do research, but want to make an impact eventually with this direction of work. Like how, what have you learned about this process? And the more kind of like concrete and specific you can be, the better. Like how you work solo, how you work with other people, like what your philosophy on it is. Very curious.
Yeah, these are really good questions. I do like trying to talk about this, but I find it super difficult because I do think that I have a fairly, different approach. And I don't know that my experience is so replicable. So I think about that a bunch, but there's a bunch here. I mean, the first thing is kind of the split. And I think you kind of may have already talked about this before. It wouldn't surprise it comes up, but there's this pretty recognizable split of the parts of science. Like you've got rigorous validation, but also like ingenuity in picking a direction, forming a hypothesis is not like derived from a recipe that requires this kind of whatever it takes to build the conviction to go, choose a direction based on that has to come from this like picking out of possible uncertainties. That's hard to really pin down. I think that because I started in graphics before switching to crypto and security in the first place, so I think have a lot of because I would say I'm interested in like gameplay mechanisms and kind of pursuing, a concept until you find, what's surprising about it. And I think that's a lot of like a good research intuition feels like, well, some things that are really motivating, or when, someone's wrong on the internet, you feel like motivated as soon as it's really great in research to be motivated by a contrarian thought. Because this is even just explicitly the language in it's desirable to refute common wisdoms and, point out that a, prevailing direction is actually wrong for some reason. It's hard to say what it's like to get an intuition that something like that is, available. But once you do, that's like, I guess it's like trying to pick a trading insight. Like you want to go short on something you think everyone's pricing incorrectly. And then I'm trying to be more attuned recently to the way that, product people operate. And I guess I've observed what is this, product roast sessions that are a lot like, research discussions or debates that are in some way speculative, because it's what you do before committing the effort to, fulfill a hypothesis. So it is in some ways, can you cheaper than actually carrying out the expensive validation, have good reasons to, predict it or something. So, I mean, there's a lot of like, pitching ideas to VCs as part of the crypto startup space. People who can do creative direction that is product informed, has to do with anticipating what a consumer market will react. And then, teams of researchers or a bunch of professor colleagues kind of picking directions or writing a proposal. They'll be, in a way, anticipating, what's going to be, reviewer committee, grant committee market fit for the research ideas. So, I mean, in the same way, there's like a need for, I'm interested in this difference of like products have market realities that they have to face as kind of their validation. And then in science, you have this peer review process where your validation gets checked. And, you're supposed to pick methods that are kind of naturally falsifiable. Like you do an experiment, you carry out the, structured theory analysis. So, I mean, those are kinds of, I view these as kind of systems with some overlap that's kind of yet to be determined, what best to do with it. So I am really interested in this kind of, for me personally, I spend a bunch of time in, I guess, high school and undergrad before doing research, thinking that my destiny was to lead an open source project or be a maintainer of, I was really interested in, the open source, I guess broadly, like GNU and open source things broadly. But, it was all tempting to burn out because there's no end, and can't really do anything except just admit defeat once like it's spiraled to irrelevance trying to start some project. Really tough. And research is kind of nice that it has a natural cadence, like you fire off the paper at the end of the semester or at the conference deadline, then you have a relief and you're kind of allowed to go pick the next thing. And that's like way healthier in a way. So I'm kind of intrigued by how, I guess, product life cycles, more or less carry that. Smart contracts are supposed to be sent and, be forever. Does that mean that any DeFi project like only has a failure condition or stuck with it forever? I find that kind of interesting.
Yeah, there's definitely a parallel. Into the Bytecode is sponsored by Splits. Are you tired of sacrificing security for usability? Splits believes it's still way too hard for teams to self-custody their on-chain assets. They're building a new kind of internet-native bank on top of Ethereum. Splits makes it easy for teams to manage the whole lifecycle of their finances, from structuring revenue sharing agreements, using payment flows like splits and waterfalls, to managing those earnings once you receive them, using passkeys and smart accounts. Splits is being used by teams like Protocol Guild, Zora, Songcamp, and others. I'm a big believer in them and recommend checking them out. You can learn more at splits.org. When you're talking about kind of like having a feel or an intuition for what's a contrarian what's the seed of a contrarian idea that like goes against the common wisdom. Um, is that like a mindset that you actively hold? Also, I'm kind of, it makes me think that they're like, that's one way of thinking about potentially interesting directions, but it's still kind of defining itself in opposition to something that's out there, right? And then there's like another way that this might happen, which is like it's purely out of like curiosity, and there's like more of a blank slate. Like you're, I mean, I don't know. Like if you think about to the beginning, to when Bitcoin, kind of first came along. I mean, I guess like Bitcoin itself was building on a lot of prior work as well. So like nothing is like net new to the extent that we think it is.
Yeah, I do think about this a lot in terms of like is like being contrarian isn't always a virtue. It does sometimes go well with finding disruptive, or in general, it relates to novelty seeking in research. So a lot of research structure and a lot of the role as like an advisor really is just separating the tasks of different grad students so they all have individual work of right sizes to be able to graduate and get published. So, I mean, collaboration is preferable generally. A lot of the things that I think are rooms to improve on in how the startup ecosystem functions is a lot of redundant, like either overbuilt infrastructure that doesn't address the right problems, or is too much redundancy when picking a winner early on might have been better off for everyone, just in projects, conventions, languages to follow, that sort of thing. Um, Academia has a lot of explicit pressures for novelty, the whole way that citations, reviewers have to reject things that were just published, a while ago, tiny grace period for concurrent work, but then you have to disclose it. That's like super novelty. That's an explicit mechanism that hugely fuels novelty seeking. Startup companies aren't under the burden to do that, except to the extent like, oh, you're just doing this for that, pitch, but they're not obligated to, not publish it, not fund it because something's already, similarly published. That mechanism isn't present there. So is that good or bad to kind of include? I'm not totally sure. I mean, picking a thing and going along with it is a little bit different than being contrarian, but that seems like one of the best ways of generating, I guess, novel directions of all. And it's interesting how the NSF funding experience goes, because there's this weird, incremental is the dirty word and transformative is what you're supposed to aim for. And I guess one way I try to explain this, I'm not sure how good this is, but is like, an ideal research portfolio is some kind of, like pyramid with like some chance of a breakthrough that's, really exciting and impactful, that would have that kind of contrarian changes everything kind of view. And, maybe you're okay having a bigger chance of, some sustained contributions, and maybe a pretty good chance of having, a few important papers. But if you can't even articulate what a breakthrough would be, then, maybe you're not exposed enough to the, chance of a, really impactful kind of thing to find. But and I also suspect it kind of just comes to preference, and then maybe I have like a high interest in that as like I don't know, enjoy the contrarianism for its own sake. I guess it's just a part of preferences.
Yeah, totally. What about the actual like process of making progress on a kind of like difficult open-ended research question? Like if you introspect on that, is it like reading and consuming kind of like adjacent works? Is it kind of like having collaborators that you're bouncing ideas off of? Is it like theory versus like prototyping things? Like how what does this process look like for you?
Yeah, for me, I would say it's probably for three things. I would say the first one is rapid prototyping. Maybe this comes from like a preference for me, but I mean, I started to do a bunch of theory related things in cryptography, not by cryptography standards theory, always applied, but to me, very theory. But that came later. I was like comfortable as a programmer and doing research engineering for graphics before doing that. So there's an element of being able to do quick prototypes and simulations, or just working prototypes in cryptography and distributed systems that I'm fascinated by the difference between proofs and test cases, because you don't make an example illustration and that proves that there aren't other cases, and yet it's also the most, useful thing for making something more concrete. And then making anything concrete as a demo builds so much more understanding that it's like the right thing to do in almost every case. Do an implementation, even if you're just doing it for research, because it will, just by making it concrete, it unlocks, much better thinking in terms of what can come afterward. So I highly value doing implementation. And if you have a hunch as what a thing is, but it's hard to formulate the research question, then, at least building in some direction, a little bit can be helpful as well. I'm really interested in like the mode of work that I see a lot of companies do. And then also some of my grad students acclimated to this, but hackathon driven development, where you do these kind of coordinated bursts of development work and present them, kind of micro research projects. I mean, they tend to do these by traveling around to the different conferences, which is kind of, difficult to do for ordinary grad students. But, somehow that pace and, really time boxing yourself to, do something quickly, but it's got to work at least well enough for a demo. I think that's a great, it's also a good unit for fostering collaborations, because it's a good, like, we'll team up kind of cross institution for a pretty narrow banded duration, but so I've had a bunch of experiences now where like doing that kind of rapid prototype for a research project, like all the great experience was done in a pretty short, maybe 2-week period for an intensive one. And then, probably several months to write the paper and do formalism afterwards. But that's, I think a pretty good flow.
Yeah, that makes sense. Okay, next fun question is, I mentioned I went down a big rabbit hole with your YouTube last night. And I feel like a lot of people don't know about this YouTube, but it's a gold mine. And I felt like I felt a kind of a spiritual kinship with how you're kind of a troll inside, I would say. And these videos, like there's these like 3 to 5 second videos. I think one of them has like 100,000 views. I forget which one it was, but there's one of Ralph Merkel mixed to some music. I had more of a lighthearted question and then more of a sincere question. The more lighthearted question is like, one, how did you get into YouTube? Because that's like pretty early on. Like, I think, you were definitely an early adopter there, given some of the videos you have. And then 2, maybe adjacent, because I feel like it maybe also dates back a long time. What is the story behind the rooster profile photo?
Oh, right on. Well, I mean, the rooster's a local celebrity for my hometown. There's like a rooster in an area of town that had a lot of roosters, but this one flew to the other area of town and hung around the cool boardwalk with restaurants. And his name's Herbie Hancock, and he's in some newspaper articles. So there's even evidence that this isn't just entirely made up. But it's a photo I took of the hometown mascot, and I've adopted it as such.
Nice.
Yeah, and I'm sorry, what was the one right before that?
YouTube.
Okay, yeah, just how I got on YouTube in general. Oh, nothing super interesting there. I think I got into Twitter pretty early, like in 2009, just by following. I had more cool and plugged in friends in undergrad, and they were pretty early to things like iPhone development. I was pretty slow to get a smartphone. All my friends had it. I was pretty slow to join social media. All my friends had it. So it was like a semester behind on them for all of those. But yeah, that's still pretty early.
Mm-hmm. And then the kind of more sincere question that I wanted to ask you was, I watched your Bitcoin unboxing video, and this is, I mean, it's so worth watching. One, because it's hilarious. So you're basically trying to make the case in 2011 that there's useful things that could be done with Bitcoin. And you've bought a bunch of random things online, including bit jerky, like this homemade like beef jerky that's, made by someone, and you paid Bitcoin for it, and you're like eating it on camera and unboxing it, which was really cool. But to me, it was also like kind of captured just this like spirit of, I mean, it's like, it's hard to imagine that Bitcoin really started as like nothing, right? Like people were like just mining this like, kind of useless internet points and sending them back and forth. And the fact that someone's like willing to take payment with these things and like do something in return was like a mind-boggling concept. And like the kind of like playfulness and the earnestness of people just kind of like tinkering with things, and like when there's like nothing, when there's like no expectation. I mean, there's some maybe sense of like where this could go, but like, you know, in one's wildest imaginations, it's like hard to imagine where we are today. So I really kind of like respected and admired that. But it made me think to ask you the question of just what was it like back then? Like what was it like being in Bitcoin back then?
You can even go, I spent a lot of time on the Bitcoin Dev and Bitcoin Wizards IRC channel. So I think those are all logs. So you can probably go find a bunch of embarrassing conversations that I would have had before, during the whole like switching to that as a research topic. I was so expecting Bitcoin to fail throughout, I guess, not anymore over, you know, a few years, but probably also way longer. I was skeptical then, you know, that it would. I was pretty happy of having carved out what I thought would be a good theoretical direction on these, like, you know, puzzles and anonymity for, you know, organizing a consensus network without assuming a PKI, and that would still be a good theory direction even when Bitcoin would inevitably, you know, stop. But I mean, useful's always been tough, but I became really satisfied with like, it's at least doing weird, different, not the same thing, you know, kind of thing. Like obviously there was PayPal and eBay, but it's pretty easy to see Bitcoin being, you know, actually different. And there was a pretty crazy time period of Bitcoin development on IRC with some things that I was a huge fan of and tried to write research papers about at the time. I don't know how many of these are still available to read, but like there'd be a developer channel and there'd be a trading channel with a little bot. I mean, not AI, just scripted, just IRC, carefully hand scripted IRC bots, but they would take your order, they would authenticate you using GPG interactions. You'd talk cryptography in a DM with the bot, and it would authorize you to, you know, post and buy and sell orders. This was just a very free form message board Bitcoin OTC with this IRC bot integration, and it had a reputation system, a little like graph that would show you like who you've rated and that you're, you know, contemplating taking up this OTC order with someone who's traded with someone who you traded with, and you know your graph is this deep of trust ratings. And people were doing their best to set up these e-commerce websites, and I mean it was pretty obvious that like the Silk Road was capturing all of the attention of, you know, people, and maybe that was what was useful about it. But besides that, there were all of these just really earnest early adopters that were like, have some weird niche product. There was like alpaca socks and these custom lollipops with all sorts of weird flavors. And then just a long tail of weird stuff being traded from Bitcoin early adopters, but they would post with the IRC bot, they'd register their little order, you could talk to them by DM and, you know, trade Bitcoin and ask for a delivery. And so, yeah, I feel like, and I can still continue to think, and it's come out on a couple of things with like, you know, rapid prototyping, but, you know, making things real, making things a demo, actually interacting with them, making it as visceral as possible. That goes, I think, a really long way towards, you know, fueling your inspiration. You at least want to like save your checkpoint on, you know, feeling the reality of everything that's, you know, in range of being real. So, yeah, I'm fascinated by how those go. I think the first unboxing was just Bitcoin. The second one focused on what was available for Zcash. I probably have to think of another one next.
You had some spicy hot sauce.
Yeah, exactly. The hot sauce vendor. That was good.
Yeah. What were the people like at that moment in time with Bitcoin? Like, do you have, are there any like memorable characters that you can think back on, or like people you were like friends with or are still friends with? Like, I'm just curious, like what the social, I mean, it's just like such a weird, like interesting thing to be into.
I think I pretty quickly filed into my academic, you know, subset of those, but there was this like Bitcoin development and research and Bitcoin talk forum and a bunch of things from there. I think there was a period of time where that was like super Interesting. I mean, I guess there were a couple of things. Like I thought that there was this transition of, I think, interesting contributions to research like applied cryptography and consensus protocols and the like that really started to come from these developer areas where they were previously areas that I thought were, universities had dominated. Like reflecting on the virtual reality, augmented reality research direction from before, that was something where universities maybe weren't doing the cutting edge, and industry was in some ways doing a much better job of the innovation of virtual reality and stuff. Maybe that's continuing now. On the other hand, in cryptography, it's like all of the cryptography theory work is done at universities, and companies are mainly organizing things that had already been put together. And universities would be the innovators in cryptography, especially regarding formalism and anything ZK, for example. And so there was a ton of collaboration, a ton of really innovative posting on the Bitcoin Talk forum and Bitcoin developer mailing list. I became really interested in the interchange between academia and the developer community around that time. A lot of which just ended up coming in the form of like writing survey papers on all the interesting topics the Bitcoin Talks forum is doing, trying to do translation of things crypto people are looking at into these different fields. And I would say I noticed one by one subfields within computer science mainly catch on to Bitcoin and basically accept it, go over all of the open problems that are open, try each of their tools from their discipline and see what they do there. I think it started with the financial cryptography, applied cryptography kind of crowd immediately picked it up. I think then distributed computing and cryptographer theory, and then algorithmic game theory and other things like that, maybe. But it was like different subfields of CS, kind of all time staggered, but going on in some way. The smart contract, failures, got a whole visit from the formal methods community and so on. And that's a lot of these have then continued and not just been pick it up and leave, but certainly go through an onboarding of the research field to the new viewpoints of Web3. So that's been pretty interesting. And yeah, I'm intrigued now by I think how the various ecosystems and whether portcos or like aligned but separate industry participants kind of collaborate and or compete is I think super interesting. I mean, and it relates in some ways to I think how research and development work in academia. There's some differences in the incentives and limits to what they can do, but I think that continues to be something that's like a pretty active area. I've also seen a ton of people basically conclude academia, exit it, go to professor coins, or heavily involved in startups in some capacity. So that flow and correspondence is there. But I guess I kind of think that there's still some low-hanging fruit of some kind that would be opportunities to do an even better job of this kind of organization. Yeah, tough to say.
Mm-hmm. Well, and as a last question, I thought we would zoom way out. And I asked Quintus beforehand what might be interesting things to talk about together. And he said to ask about your overall vision for where all of this might be going, and that you've been thinking about cypherpunk, lunar punk, like these sorts of things. I don't know exactly what he's referring to, but what's there?
Well, I'm sure I don't have one coherent vision of this, but I don't know, evolving a bit, bits or pieces. I'll try out an answer. So, I mean, I think that where the direction that all of this heads to me, and I think has been pretty consistent through all of these, is I think most fits in with coordination, or like the real goal of this is to be able to do much more effortless coordination of humans across the globe. And that you can see bits and pieces of this promise from a lot of existing, cypherpunk systems, whether it's public ledgers that make cooperation good, or like anonymity makes it easier for people in different jurisdictions to be able to cooperate. Doing decentralization also relates to robustness of networks. So essentially the ability to cooperate even in the face of, people trying to inhibit cooperation or set up gatekeeping roadblocks, whatever. Decentralization and anonymity are good kind of inputs to that. The vision somehow has to be that where this is headed is that you can much more easily form teams, make productive trades between people across the globe. Long tail of matchmaking for things like being able to bring expertise where it's needed and kind of assign. I think that some of the most interesting experiments of these have been DAOs, especially the ones that focus on I think a lot of them basically get stuck on like token-oriented governance and like choosing proposals, which is kind of pushing the actual work of performing to, the recipients of the grants, although that's already kind of cool, structured on-chain supported decision-making. I think that the ability to draw in these new kinds of resources and sensitive data, and even that it's going to turn out to be useful to focus on, AI agents for these, but what they suggest is like how you can do better organization of competitive people with their own sets of unique resources and abilities, but some ability by aggregating together can do better, constructively. And the ability of smart contracts, especially privacy-enabled ones, and especially ones with the ability to act on other kinds of assets like Web2 accounts. That's like really what's going to turn out to be able to unlock that. And so I think broadly that vision's kind of shared by I really like the people who talk about coordination in these views. So anyone working on decentralized organizations and governance, I think are pushing in those kind of directions. I think that the ability of privacy tools that you get from the TE kind of experiments especially isn't yet priced in these. So I think that's going to be really useful for making more clear where that can go. But yeah, that broadly.
Amazing. Well, I think we can bring to a close there. Thanks so much.
Awesome. Thank you. This was a great chat. Thanks.
Hey, I have a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really appreciate if you leave a rating and a review for the podcast. It might seem like a small thing, but it actually makes a big difference to help other people discover the show also. Thank you, and I'll see you again soon.